All right, John. So the last thing that we're going to talk about today is measures of dispersion. And that kind of sounds like, all right, I have no idea what that means, but it's actually not that bad. Measures of dispersion. Dispersion is just another word for disperse. And what does disperse mean? Disperse means if something disperses, it means that it spread out everywhere, right? So if we're talking about statistics and we're looking at measures of dispersion, all we're looking at is how spread apart are my data points? How far apart is all the information that I'm given? Because maybe we're studying something and all the data points are really close together. Maybe we're studying something and we have a 93 and another 93, and we have a 97, and we have a 95, and a 94. And all those numbers are really, really close together. We're going to talk about what it means when the numbers are really close. Versus somebody else does a different study, and their data points start out at 2, and then they have an 18, and then they have a 26, and then they have a 99, and then they have a 74. And all those numbers are really far apart. What does it mean when numbers in a study are really far apart versus when they're really close together? And that's what we're going to talk about with measures of dispersion. And there's a couple of different kinds of measures of dispersion that we're going to use in statistics. And it's okay because, like before, it's all stuff that's in your calculator already. So it's not that bad. Measures of dispersion. And I just told you what measure of dispersion means. Dispersion just means spread out. So it's really the measure of spread. Okay? Alright. So we are going to, I'm going to teach you about 4 different measures of dispersion. And it's really easy. It's not that bad. But as we talk about each of those measures of dispersion, we're going to keep coming back to these 3 students. We have Hannah, Marissa, and Bianca. And they're all girls, and they're in Miss Tompkins' class, and these are all their test scores for all the tests that they got over the last 5 chapters. Okay? So as we talk about each of those measures of dispersion, we're going to keep coming back to these 3 girls. So the first measure of dispersion that we can use is range. Actually, before I do that, what I want to do is just go through, and I want to just take a look at what kind of students these girls are. So normally we kind of like compare students based on their averages, right? So let's just take the average of all these students. So Hannah is the first girl. She has an average of 85 plus 84, and I know that I could let the calculator do this for me, but I'm just going to do it really quick. 83 plus 86 plus 87. Actually, you know what? That doesn't make sense because we're going to need to use this stuff later. So let's go to Stats, Edit, and you know what I'm going to do just to make our lives easier? I am going to make Hannah our list 1 girl. Marissa is going to be our list 2 girl, and Bianca is going to be our list 3 girl. So I'm going to list all of their scores in list 1, 2, and 3, and that way, whenever we have to find out something, we can just always refer back to those lists. So Hannah's in list 1, so she has 85, 84, 83, 86, and 87. Those are her scores. And let's just figure out what her average is really quick by doing 1 variable stats. And let's take a look at list 1. And Hannah's average is an 85. That's not too bad. She's a pretty good student. Let's go back to stat, into our list, and let's list all of Marissa's scores this time. So 79, 98, 68, 94, and 86. So we're going to see what her average is by calculating 1 variable stats, but this time we're going to say, hey, this time my information's in list 2, because we're looking at Marissa. And her average is an 85 too, which is pretty good. Okay. And go back to stats. Let's edit one more time. let's go into list 3 and let's list all Bianca's scores. 68, 87, 98, 86, and another 86. And let's go to stat, calculate one variable stats. This time I'm going to look in list 3, hit enter, and Bianca has an average of an 85 too. So technically speaking, if I were the teacher, in my grade book, every single one of these girls has an average of an 85. So average is typically what we use to figure out like how well students are performing in our class. But what I'm going to talk to you about right now is how maybe the average isn't necessarily the best use of information to tell us how kids are performing in a class. So we're going to talk about the measure of spread, the measure of how spread apart their scores are. So there's a couple of different ways that we could do this. We could look at a range. And the range, like I said before, remember there's the range and the interquartile range. The range is just the maximum minus the minimum. It wants us to know how spread apart that whole set of numbers is, all the way from the maximum to the minimum. And the difference between the range and the interquartile range, the interquartile range is just Q3 minus Q1. So the interquartile range, instead of looking from the maximum to the minimum, it's looking from here to here, from Q3 to Q1. Alright, so those two different types of measures of dispersion are going to give us two completely different numbers, and let's take a look at what that means for our students. So if you look at Hannah, Hannah's scores are all, around 85. She had an 85, she had an 84, she had an 83, an 86, and an 87. So what I see when I look at Hannah is I see 1, 2, 3, 4, 5 scores that are all in the range, all around the same range. They're all really close to 85. It looks to me like Hannah is a really consistent student. It looks like all of her test scores are right around the same range. So if you find the range of these girls' scores, the range is just the highest minus the lowest. So Hannah's highest score is an 87. Her lowest score is an 83. So her range is just 4. So it looks to me like Hannah is a very consistent student. Versus Marissa. Marissa had a 79, which is not too bad, and 98, so she had an awesome day. And then she drooped right back down to a 68. Then she had a really good day again, which was a 94, and then an average day again. So I only really see 2 scores that are even close, really, to what this average is. Let's figure out what her range is. The range is the highest minus the lowest. So her highest score that she got was a 98, and the lowest score that she got was a 68. So Marissa's total range is a 30. So that means that Marissa is not as consistent of a student as Hannah was. You see how all of Hannah's scores were within 4 points of each other, but all of Marissa's scores were within 30 points of each other. So you can tell that she's not as consistent of a student. Sometimes she has really good days, sometimes she has really bad days. And let's take a look at Bianca. Bianca had a 68. Whoa, not so good. Then she pulled it back up to an 87. That's kind of close to her average. 98 is really good, so she had a good day. And then she had 2 more scores that are kind of close to her average. Let's figure out what the range of her scores are. She had the highest of a 98 and then an 89 as well. Her range is a 30 as well. So you can tell just from this information that, number one, averages aren't always the best indicators of the kind of students that you have in your classroom. Okay, because clearly Hannah was doing a better job because all of her scores were really consistent. I'm going to write that word up here because it's really important. Consistent. Maybe that's an A. This is why I'm a math teacher, not an English teacher. Consistent. Whatever. Okay, consistent. Hannah is a really consistent student versus Marissa and Bianca. Their scores are all over the place. They're within 30 points of each other, so that's not very good. But you can tell that the range was only good enough to tell us that Hannah is better than these two, but we still need another way to tell who's better. Is Marissa better or is Bianca better? So the range is a good way to tell us who's consistent, but even more so, maybe we can use the interquartile range, and maybe that'll give us an even better indication of who is a better student. So what about if we do the interquartile range right here? Alright, and in order to find the interquartile range, we have to use the calculator because that's going to do it for us. So remember, Hannah's information is in L1. So I'm going to go to Stats, calculate one variable statistics, and I want to look at Hannah's information, so L1. Okay. Remember, interquartile range is Q3 minus Q1. So Hannah's Q3 is 86.5 minus 83.5. So her interquartile range is just a 3. That's really, really good. Let's take a look at Marissa's now. Clear that out. Stats, calculate one variable stats, and this time we're looking at Marissa's information in L2. And we want to look at her interquartile range. So 96 minus 73.5. So 96 minus 73.5. And that's a 22.5. Way bigger than Hannah's. But we're not really comparing Hannah to them right now. We want to know who's better, Marissa or Bianca. We know Hannah's the best, but we want to know who comes after that. Alright, so let's look at Bianca's scores. Stat, calc, one variable stats. Let's take a look in L3 this time. And Bianca's interquartile range goes from 92.5 to a 77. 92.5 to a 77. 15.5. So you can tell that average only helps us so much to figure out how students are doing. A range would more tell you how consistent the student was. And the smaller the number, the more consistent they are. Versus the bigger number, the less consistent they are. But even more so than range, the interquartile range told us even more information. See how Hannah is clearly the best because the lower the number, the more consistent you are. Then comes Bianca because she is, has the medium consistency. And then Marissa comes in third place. She is the least consistent student in the class. Okay? I'm going to stop this right 1 second, and then I have one more thing to tell you.